So we're now going to start looking at a second peripheral, the timer counter. And we're going to use and start off at a place similar to where we were in video 2, where we set up the LED to toggle every 500 milliseconds on using a delay. Interrupts are much better because it allows you to go into sleep modes. It also is much better than a delay because it allows the processor to do something else. We are going to start off where we were before, and looking at the data sheet, we see that we have a timer. So let's just start with timer counter 0. It's an 8-bit timer, and you can see the block diagram here of what it looks like. There's some control logic, there's an overflow interrupt, that's what we're going to try and use. There's a prescaler in, and some control logic. And okay, then the output compare, we'll look at that perhaps in the next video. So just scrolling down, look at the basic compare match functionality, which means that we have an interrupt when the timer overflows, or when the timer is set to a particular value. And here we have the equation of how to calculate the frequency. So there is n here represents a prescaler, and you can see that there's an option of 124. So if we want to calculate the frequency of overflow of the 8-bit timer, 16 million, which is our CPU frequency, 2 times 1024 times 256, which is the highest that 255 plus 1, the highest that we can count to with an 8-bit timer. So we can see the 8-bit timer is only good for really short things. To interact with people, well, it's going to overflow 30 times a second. So let's rather go to look at the 16-bit timer, and it's the same thing that we want to look at. So modes of operation, clear, timer on compare match. You can see that the diagram, the frequency is this. Well, the equation is the same. And so let's scale down the prescaler maybe to 256. And the maximum we can count to is 65,536. Okay, and you see this works quite nicely for us. It overflows pretty much twice a second. So now let's go to the register description and see if we can set this up. So just scanning these tables, we see that normal mode of operation, all these tables, normal mode of operation. So there's nothing we have to set up in the first control register, timer counter control register A, because it's not relevant for us. Timer counter control register B, well, here we have our prescaler selection, and we know that we wanted a prescaler of 256, and also if you don't set this, then the timer counter is actually stopped if there's no clock source. So we need to therefore write to timer counter control register B, and the bit that we wanted to write to was CS12 for a prescaler of 256. Okay, so we've turned on the timer, we've set the mode of operation, which is just normal mode counting, and now we want to enable the interrupt. So is there an interrupt? There we go. Interrupt mask register, and I'm going to guess it's this one here, the timer counter overflow interrupt enable bit. So now We used interrupts before with the GPIO. Go check out some of those earlier episodes if you didn't see it. But remember that you can see here AVR interrupt.h is our include file. Okay, and the other thing to remember is enable global interrupts. And now we must implement our interrupt service routine. Going back to the data sheet here, we can see that the timer overflow 1 interrupt enable. When this bit is set, status rigid, the overflow interrupt is enabled and the corresponding interact vector is included. So this takes us back to the interrupt chapter. And we must just make sure that we're looking at the right part, which is so it's the overflow vector, timer 1 overflow, and so this is what we want, timer 1 overflow. And we want to toggle our LED here, so we take this out. Okay, so let's see if we've done everything right. And similarly to what we did before, we'll set a breakpoint here and run it. You can see we're hitting the breakpoint. We are executing interrupts, and if we disable this and run, you can see that our timer is overflowing almost the same frequency it was before. Perhaps in the next video we'll make that a bit more precise.